go on page 92 when we are finished. Look at trapezoids, rhombi, and kites. So trapezoids, the area of a trapezoid is something you should have already found and know how to do and know what the formula is. There are two forms of an area formula for a rhombus, because a rhombus falls under what category of special parallelogram? Oh, well, I just gave it away. Special quadrilateral. It's a parallelogram. That's what I was going for. So you can use the area of a parallelogram formula for a rhombus. That works. But then there's also another one depending on what information you're given. So we'll look at the other one. And then the area of a kite is definitely going to be new to you, because most of you didn't even know that was a geometric figure until we talked about it the first time. Okay, so quick little review here. Area of a rectangle. So we're going to draw a little rectangle here. Well, that's all wonky, but that's okay, because then we label it and it's fine. So if we have a rectangle, then rectangle, this is the height of my rectangle. Right? So the formula that you may have seen before and probably learned at some point, the area equals length times width. That goes in trash can, okay? Every formula that deals with a height and has any sort of base in it uses base and height, and they all relate to each other. So yes, you will still have problems where they talk about the length and the width of a rectangle or whatever, but the formula itself that you need to use and understand is not length times width, because that lowercase cursive L actually means something else and as well, and it will get very confusing in the near future if we don't. Is equal to base times height. You need. Okay, everybody good with that? All right, so then and this is the base of my parallelogram. The height is not one of the other sides, right? Because the height is always related to the base how? Perpendicular. We're talking two-dimensional figure to the base. Always perpendicular measurement. So even the Leaning Tower of Pisa, when you talk about the height of it, right? The height is the perpendicular distance from the top to the ground. It's not how tall the actual or how long the building is or whatever. All right, so we can draw ways. It can also go on. Is actually the altitude, and then the altitude is the perpendicular distance to the plane of the base, because notice that height doesn't actually even touch the base, right? But just another little dotted line there to show you that it's touching the plane of the base, and the height would be the same measurement regardless of where it was labeled. Okay. So then the area of a parallelogram, and we do have a little shape for a parallelogram, so you have a little subscript. It is base times height, just like a rectangle. But actually, it's that the rectangle formula is just like the parallelogram formula, because a rectangle is a parallelogram. Okay. Not just a P, it would have to be the word parallelogram or that. Okay. Area of a triangle. So, I'll draw two different triangles here. There we go. So this could be the base of my triangle, this could be the base of my triangle, right? Height is always perpendicular to the base, so you can have this. Oh, so I should might have to pretend. There's my height, or it could be on the outside, like this. Same thing, it's perpendicular to the plane of the base. Formula of a triangle is equal to base times height. This whole equals base times height over 2 goes in the trash can. Right? Because you're going to have stuff that you have to substitute into your formula, and you do not want fractions that you substitute in, then you end up with a fraction and a fraction, which really isn't that bad, except y'all usually freak out over that. And so it's way better to use this. But I hear people say, well, I like that one because I don't like fractions. Well, that's a much bigger, scarier fraction than that is, so I don't really understand that logic. But this is what you want to stick with going forward, trust me. Okay. We good? Yes? Okay. All right, so now we're going to find the area of the rectangle. So every problem, you start the same way. Draw a picture. So it is a rectangle. The next thing that you do for every single question, what? Base times height. And you substitute it in and solve it. Do that. To multiply this together, raise your hand if you would do the box method. The box method. If you don't know what I'm talking about, then you probably wouldn't be raising your hand. Okay? And raise your hand if you do distribution. Okay? Raise your hand if you do FOIL. Raise your hand if you do something else. Okay. I'm just curious. I mean, it's kind of all over the place, and that's what I thought. So I don't care how you do it. You do whatever makes the most sense to you. I'm going to call it FOIL. But if FOIL to you means distribution, or it means to you the box method or whatever, it's all the same steps in the end anyway. It's just how you organize it, so it really is fine. No. That's why I don't use just say one thing, because I want you to understand there's different ways to do it, and you all get the same answer in the end. So before I actually combine it into, when I do this, whether I'm doing the box or whatever, I squared minus plus 3x minus 6. Do we all agree with that? Yes. So then we get that the area of the rectangle is equal to x squared plus x. Then what? Units squared? Or do I set it equal to 0 and solve it? I'm done. I can't do anything else. Sometimes your answer has x's in it, okay? And you have no way of knowing what and if you're going to set it equal to 0 and solve stuff, you're still not getting what you think you're getting. Like, you don't have enough information to actually solve for x. I can find the roots or the zeros or the solutions to that quadratic, but that's not x that would work. It's the ones that are there at the zeros. So parentheses, I heard somebody say that, so good job, and inches squared. Okay, there's your answer. You have to know when your answers have variables in them and when they don't. You have to be able to reason through the problem. Does it make sense to have variables, or do I have enough information to find the variables? And sometimes you don't. And that's something that you have to be able to process in your thoughts. All right. So then the rectangle. So I'm going to draw my picture. My rectangle. So my base is 15x. Now area, so what I usually do with the area, especially if we have composite figures, which we will have a lot of. I don't think I started off much on this one because I wanted to review some things. But when you have to find areas of different pieces, always write the area on the inside, so I know it's not a measurement. So put like a equals 150 x squared. Not like a rule or anything, but it's kind of what's happening. Is what I'm looking for. All right, so I write down the area equal to base times height. And I substitute everything I know. I know the area. It's 150x squared. That's equal to the base, which is 15x, times the height. What am I solving for? H, the height. So sometimes you have to remind yourself of that. Aren't you used to solving for x? Could I solve this for x? Yes. No, I could. I could solve this and get x by itself. I totally could. But that's not what this question is asking for, and I'd be going in the total wrong direction. Right? So what can I do? So then I get h is equal to, pull out right here, right? What does that give me? 10x. And they didn't give me any units. So if they don't give you any units, then you can use U for units. And would it be units or units squared? Just units because it's the height, right? So putting the incorrect units on these, I will take off for that, not because, well, because part of the teaks that I have, it says with correct units, is that if you put units squared on there, that tells me you have no idea what you're actually finding and what any of it means. You have to make sure that you understand what's going on with the problem. All right, we're looking for the area of this parallelogram. All right, so they do the picture for me, that's good. Do you know the base? Yes, what is it? 11. Do you know the height? No, we don't. Do we have information to find the height? Yes, we do. Okay, so this is the height. Does it really help me right there? No, what could I do? Move it over. Couldn't I can shift it, right? It's the same thing. I'll slide it over. If I move it over here, I get a little 30-60-90 triangle, right? So this part, which is the long leg of my right triangle, is the height. But in order to short leg, and I didn't give that to you, they didn't give me the hypotenuse. So if this is the hypotenuse, 9 over 2. Okay. And that means that the height is some of you need to go review your special right triangles, and guess what can help you with that? Alex. So you can go in there and review that if you need. Because it's a 30-60-90 triangle. S, 2S, S squared to 3. Okay, hypotenuse is 2S. All right, so I've got my height now, and I've got my base. Now I can come back over here and substitute it times the height, which is 9 squared to 3 over 2. I highly suggest when you are multiplying something that's not a fraction by something that is a fraction, that you put it so you don't do something ridiculous, like multiply the numerator and denominator by 11, which makes absolutely no sense. And then those two together, I get over 2. Can I reduce that at all? No. Just get that ugly looking answer, and that's what happens sometimes. What do the units look like? Is the area of my parallelogram. Good? Any questions? Okay, do you see now why we went over and over and over and over special right triangles? Because that's just going to be in other things that we do. All right, so now I need to find the area of this triangle. So area of a triangle formula is what? 1/2 base times height, right? And do we know the base? No. Do we know the height? Yes. If you have a right triangle and you can use the legs as the base and the height, go for it. I use 20 as the base. If I did, then I don't want to make it harder. But can I find B? Yes, with Pythagorean theorem. So it's going to give me 12 squared plus B squared equals 20 squared. Let's go ahead and do it. Perfect square. It is. It's 16. And remember what we talked about the other day? How if you can at least recognize it as I know that's a perfect square, then that what your numbers could possibly be, right? It's 15 squared. Y'all know what that is, right? What is that? 225. So we know it's more than 15, right? Is it like a whole lot more than 15? No. And whatever the last digit is has to square to give you a last digit of 6, right? Okay, and the more you actually go through that thought process, the quicker that thought process is. Like, it wouldn't take as long as it takes me to talk you through it, and you'll be able to kind of start narrowing those things down. So B is 16. Plus, you should just know them. onto my Quizlet and just practice. If you've never used Quizlet before, it's great. You can use it as flashcards. You can tell you want to test yourself. You can do little games, whatever. But all the perfect square stuff is there. Do it so that you know them. The more you know them, the simpler a lot of this stuff becomes. All right, so then I come back over here. I know this is 16, so I just substitute in. I get 1/2 times 16 times 12. All right, well, what's half of 16? 12. Flashcards are on there. Stump you even have got to know your times. Okay, we all good? All right, to review. It's technically not even something that I'm the area that with the x and the base, which is this whole thing, is x plus 2. The base and the height. Yes. So I substitute it in and I get 1/2 times 6x. So can I distribute that 1/2 into here? Yes, I can. Do I have to? No. You've got 3 things multiplied together. This thing, and this thing. Those are 3 terms that are being multiplied together. One of the terms has 2 terms inside of it, but you can multiply in any order. If I am going to distribute, I would distribute the 1/2 to the x and the 2. Do I also distribute the 1/2 to this? No. Because if I have, just like up here, where I had 1/2 times 16 times 12, did I take half of 16 and half of 12? No, just the first one. Or could I have taken half of 12 and gotten 6 and done 6 times 16? Yes, I get the same answer. Is it easier to do the other way? Yes, that's why we did it. But so if you're going to distribute it, that doesn't distribute it to absolutely everything. Just this next term right here. Or instead of doing that, because then I'd still have a 1/2 x and still have fractions, can I multiply the 1/2 times the 6x? Yes. And then it doesn't even affect that one, right? It's just like what we did up there. So to x plus 2 distribute that, I get what? 3 plus 6x. Can I simplify that anymore? How? No. Can I just multiply factoring things back out. Can I solve for x? Do I have enough information to find x and get an answer like the area is 5? No, I don't. That is it. That's all I can do. That is the area of my triangle. And that is, I guess, just units squared. Okay, everybody okay with that? Yes? All right, next page. Area of a trapezoid. All right, so let's draw a trapezoid first of all. And what makes a trapezoid a trapezoid? One set of opposite sides parallel, right? And it's exactly one set. That's the important thing there. So I know that if I've got this, and what I have is trapezoid. So this would be like base 1. This is base 2. This would be my height. Base 1 always have to be the top base? No. Does it always have to be the shortest base? No. Probably most of the problems you've seen and done had it as the top base and the shortest base. There's nothing wrong with that. I just don't want you to think it always has to be that way, right? So this is one of those formulas where I think that y'all get the most mixed up, or I don't know, it's a little intimidating, but it's probably because at this point it was the first formula that you ever had that had the little subscripts, and like the 1s and 2s, probably the first time you saw them or it was ever introduced to you, whenever you were first introduced to that, kind of blew your mind a little bit, like what the heck are those little numbers down there and why don't I do anything with them? So I don't know if it's just kind of like trauma in your brain and that's why we can't, keep a trapezoid, regardless of whether or not it is an isosceles trapezoid. So here's a little trapezoid, right? Triangle with its head chopped off, right? Because if I continue, since these are not parallel, if I continue these, eventually it's going to make a triangle, right? It's going to go off the paper, but eventually it's going to make a triangle. If it's an isosceles trapezoid, eventually it makes an isosceles triangle, but it makes a triangle regardless. You know how to find the area of a triangle, right? Area of a triangle equal to 1. The only difference between that formula and the formula of a trapezoid is that instead of having one base, you have two bases. So your trapezoid formula is equal to one, just a base, like a triangle. You got two of them. The height. See how it's the exact same thing? So don't make it out something way harder than anything else, okay? It's still 1/2 base times height. You just got two bases and you have to add them. Easy enough? Okay. You're going to have a way to just kind of know what these formulas are. All right, so let's do a super easy one. I'm going to show you kind of problem here. If the base is added, the height. Give me both bases? Yes. Did they give me the height? Yes. So really, I just substitute it all in, and I'm going to get 1/2 times 9 plus times 3. Now, that's what I see sometimes. Don't do this. Could I distribute my 1/2 at this point? Yes, you can. Don't do it, okay? Because then you're just multiplying more stuff. You can add and then multiply, right? I mean, that's your order of operations anyway. You can distribute if you do it correctly. I don't know why you'd want to do that. So, and give so at this point, I could take half of one of those, right? And if one of those two numbers was even, I would say go ahead and take half of it. If they're both odd, I wouldn't take half of it first, because then you're going to get a fraction. Does that make sense? So that's what I mean. Take a second to look at what you have. Don't work it exactly like all the other problems you have. Think about what would make the most sense since you don't have a calculator in front of you. It would make more sense to do 21 times 3. What's that? 63. Multiply that by 1/2. What do you get? 63 over 2. Okay? And that's it. That is the area of the trapezoid. And centimeters. If you're going to give me a mixed number or a decimal, you have to do more work. Does that make sense to you? Leaving it as an improper fraction, which so many of you have resisted along the way, is easier because you stop. Does that make sense to you? You put it into an improper, or a mixed number rather, if you put it into a mixed number, if you're going to have to go back and use it somewhere else, you have to put it back into an improper fraction. If you're going to have to substitute it back in, substituting back in an improper fraction versus a decimal, way easier. You have to just stop being so afraid of fractions. Okay? Questions? All right. All right, we're going to do this one together, just so that we can get through all this review. All right, so I'm looking for the picture. Go ahead and write my formula. Area of a trapezoid is equal to 1/2 times base 1 plus base 2 times the height. Okay? So I'm looking for base 2. So I substitute in everything I know. Did they give me the area? Yes, it is 8. 8 is equal to 1/2 times base 1, which is 3. So I've got a few options here. What we've done on some problems like this, like when we're doing, we went ahead and knock out the 1/2. Totally. Do that. Not only is this an odd, but this right here, B2, which means base 2 is what? It's 5 feet. Think smarter, not harder. You can't look at everything as like, let me just look at my notes exactly like that problem is right there, because that's not always going to work out very well for you. You have to be able to think through what is best at what given time. Okay. Any questions? All right, so let's look at the area of a rhombus, area of a kite. Rhombus would divide into two congruent triangles with a base of D1 and the height of half of D2. So if you look at this, here's a rhombus, here's a kite. You can kind of do the same thing with both of them. If this is D1 for both of these, then if I go halfway, because these, I know for a rhombus, they always get bisected, so this has to be half of the other diagonal. Does that make sense to you? And for the kite, one of the diagonals gets cut in half, and it would be this one. So if I just look at this top triangle here for both of them, this triangle here, and this triangle here. And I know how to find, so these two triangles are congruent, and these two triangles are congruent. Once I find the area of that triangle, what do I have to do then? Just multiply by 2. So we're going to start by finding the area of each triangle is equal to 1/2 base times height. So the base of the triangle is represented by what? D1 times the, what is the height represented by? 1/2 D2. Everybody with me so far? They're just substituting stuff in, right? So that means that I get, when I multiply, what's 1/2 times 1/2? 1/4. You can, not necessary, but you can. So 1/4, from places I don't know why you'd want to. 1/4 times D1, D2, not DI, I'm dotting my 1. Okay, D1, D2, that is the area of the triangle. Everybody understand where that comes from? Yes? Okay, but
can you explain that again? So you basically the 1/2 you put it on base and height. Oh no.
okay, so the triangle. I just substituted what I had. Yeah. Okay. So that's the area of the triangle. To actually get the area of the rhombus or the kite, doesn't matter, either. What do I do? Multiply by 2. Okay. So the area is 2 times D2. Okay, so what's 2 times 1/4? 1/2. So this is 1/2 D1, D2, and that is the area of a kite or rhombus. And that's what goes right there. You can rewrite it or just box it. Okay? 1/2 D1, D2. That is a brand new formula, but the good news is for the kite and the rhombus, it's the same thing. But remember, a rhombus is also a what? Parallelogram. So rhombus, you can use base times height, if you know the base and the height. If it's the diagonals that you know, then you'd want to use this one. A kite is not a parallelogram, so you cannot ever use base times height for a kite. Okay. All right, let's do the next one. So we're going to find the area of the kite. And so I write down my formula. Area of the kite is equal to 1/2 D1, D2. Oh, I keep moving. They give me D1? Yes. Did they give me D2? Yes. So I get 1/2 times 6 times 16. So which take half of? 16 or 6, doesn't matter. It's a matter of opinion, right? But half of 6 is 8. 8 times 6 is 48. Half of 6 is 3. 3 times 16 is also 48. So it really doesn't. So area of a kite is equal to 48. Okay, we all good? All right. So now we're going to find the area of this. So we're going to use area of the rhombus is equal to 1/2. On this, because this isn't where I can just plug the numbers it gave me. I want you to think about how we can find what we need to get D1 and D2 to substitute in. So maybe you think on that for just a minute. You can talk amongst yourselves. I'll let go check roll. Okay, so as D1 and D2 are concerned, does it matter? Okay, so we have one of them, right? So I'm going to say that we have D1. It equals 18 centimeters. So in order to, okay, anybody have ideas on what we could do to find D2? What? Why Pythagorean theorem? Because what's the hypotenuse? You got it. Just give me some more, Caleb. So you want me to draw in D2? Would that help? Is that what you did? Okay. Have to, but okay. So D2 is my green one. So what would I do Pythagorean theorem with, Caleb? 15 and 15? Be?
It could be a 40. No.
Well, it could. Thoughts, Molly?
You take the 18 and divide it by 2 to get 4.
Okay. Good. Because the diagonals in a rhombus are always perpendicular, right? This is one of those cases. So it doesn't work for every parallelogram, right? But it would work for a rhombus and work for a kite because the diagonals in both of those figures are perpendicular. Does that make sense to you? So I got to know those properties. So absolutely. Theorem. So I can do squared plus 9 squared equals 15 squared. What's 9 squared? 81. What's 15 squared? 225. So what's 225 minus 81? 144. Okay, good. So x is 12. All right, good. 4, 5 triangles. So x, right? Here's what you have to be careful of, and this is where some of you start to really make mistakes because you're not labeling, you're not writing stuff down, and then you just start substituting things back in after you find them. The D1 is this x right here. This is to do that before we did that. And as what some people are going to do is find that 12 and be right about the process all along, but then go and substitute the 12 in. And that's not what you're doing because you got to put the whole diagonals. Does that make sense? Okay, so now I go and substitute, and I get 1/2 times 8 4. Now, sometimes how do you break this down? It's a matter of opinion what makes the most sense to you. A lot of times we'll go for the bigger number. If I go for the bigger number, take half of 24, now I have 18 and 12, and I'm multiplying two-digit numbers. Or if I take half of 18, I get 9, and then 9 times 24, that's a single digit and a double digit. So again, matter of opinion what you think is easier. I personally think single digit times double digits better than two double-digit numbers, but that's, again, matter of opinion. Ways to handle that. Okay, 24 is almost 25. And when you have 9 times 24 means two different things. It means that I have 9 24s or I have 24 9s, right? I think about having 9 24s. Let's make that 25. You have 9 quarters. How much money do you have? $25 is $2.25, right? That's That's 25 nines. I only want 24 nines, so if it's 225, I can back 9, and I get what? 16. Okay. Or, that's not really my favorite thing in terms of money. I would do 9 times 20 is what? It's 9 times 20, 180. And then 9 times 4 is 36. And then I would add those either on my paper head or probably, if a number like this probably on paper, be a little more careful. So the area of the rhombus is equal to, there's nothing wrong with writing it down. I'm not saying always do it in your head, but this crazy work you have everywhere, that's what some of you will be better off if you cut down on that. Mm-hmm. Yeah, because you're answering a different question than what I'm asking. So now we're going to, on this one, we're looking for D1 of a kite. So we're going to write the area of a kite is equal to 1/2 D1 D2. Then I know the area. Again, 8A. That's equal to 1/2. No, right? Times D2. All right, so before I start trying to get D1 by itself, I'd like to do something with that 1/2. I could distribute that 1/2 into the A minus 4, and the 4 is even, so that's good. I wouldn't end up with a fraction, but I'd still have 1/2 A, which I'm not in love with. So instead, could I multiply both sides by 2 to get rid of the 1/2? Yes. Okay, so that's what I'm going to do. And then here, the left-hand side, to make sure that I actually distribute that and get 4A squared minus 16. Over here, do I distribute this to here? No, because it's 16A. This is all straight up multiplication here, so these just cancel out. So you get D times A minus 4. Could I distribute that D1 into the A minus 4? I could, but that's what I'm trying to get by itself. I don't want to, right? Don't just do it. I'm trying to get D1 by itself. So what can I do here? Divide by what? A minus 4. I'm going to do both sides by A minus 4. Okay. These cancel out. D1 is equal to 4A squared minus 16A all over A minus 4. Right, so can I reduce this? Yes, how? Can I just like cancel A's out? Can I cancel the 4's out? No. You've got more than one term. You can't just go knocking things out. Work that way. Right? If that was all pure multiplication and there was a minus in there, then absolutely I could start reducing stuff. You can reduce this, but not in that manner. Okay? You've got one of two ways that you can do this. All right? Do y'all remember polynomial long division? Did it in Algebra 1. Okay? And so you could do the A minus. Right? So how many times does A go into 4A? Get. You don't like polynomial long division? Fine. Here's your GCF. What's the GCF in the numerator? 4A. So that gives me 4A. I factor it out. What am I left with? A minus 4 over A minus 4. Can I cancel those out? Yes, because you see the difference. This is multiplication with all of that. Bam. Either way, D1 is equal to 4A beat. Algebra 1 is not going away, just like geometry is not going away. You are expected to know how to do that stuff. If you don't, go on Khan Academy, go on Alex, make sure you can do those things. Okay? All right, next one. Area of the rhombus. Area. D2. So that's equal to times 64 times 10x plus 10. To work on that, pass out the homework. In the interest of time, I really wanted to get finished and then ask you how you did it, but could I go ahead and multiply these together before I worry about the one first? If I did, do I distribute it to all four? No. 10's the bigger number, but is multiplying by 10 easy? Then if it were me, I would just plus times 10. If you are worried about not knowing how many to multiply it by, then go ahead and multiply them and then take half. Just make sure. But what you get is, let's see, 30x squared. That's plus 20 plus 30 plus 50x squared. No, I'm sorry, 50x plus 20. Is that right? Okay, and parentheses, inches squared. Basic review, combined basic algebra review. The only new thing today is that one formula. All right, have a good day. Let's go to math time.